Hi, my name is Tony. I'm a Senior Program Manager with Microsoft, and I am here to recap a WES session titled System Design for the Modern PC. In this particular session, the focus of the content had to do with how does UEFI impact system designers, particularly OEMs and ODMs, and also IHVs that create devices which go into systems. We did a bit of a recap on why UEFI is important. We're not going to spend much time in that. However, it's important to note that for Windows 8, there are essentially two boot flows. We are enabling, because of our vast array of UEFI support, the ability for someone to create a Class 3 system. And that would be a system with no compatibility service support module services, and thereby really breaking free from the bonds of legacy BIOS. This is the preferred boot path for Windows 8 as we outline it in our certification requirements. It is also the boot path that majority, if not all, of our OEMs and ODMs are working towards, even though Windows 8 will continue to support the legacy boot path on legacy hardware. However, it is not the target of the certification program to focus on that. Most PCs today are booting through the CSM path. Even newer UEFI systems in the market today continue to use the CSM. Windows 7 itself requires CSM, so this is truly a innovation for Windows 8, and for those who want to take advantage of it, the opportunities are there for both the Class 3 system and the Class 2 system with and without CSM. So again, to optimize your designs for UEFI, as we discussed previously in the other sessions, it is important if you're an IHV to consider a UEFI-based option ROM design. It's important to update your manufacturing tools to work in that kind of an environment with UEFI. If you're an ODM, it's important to update your tool sets to move to Windows PE, and also to make sure that your native factory tools are UEFI capable. With the presence of UEFI, it becomes more and more difficult, if not impossible, to use DOS-based applications in those factory environments. It's important also, if you're an OEM, to secure your firmware while at the same time optimizing for speed. And ultimately, for the consumer, we believe that they will experience a refreshed PC that feels very fast, feels newer than what they've experienced in the past, as well as delivering uncompromising security. So our recommendations to manufacturing, as we said before, we recommend that you move to Windows PE and move away from DOS. Many OEMs already do this today. This isn't a new concept, it's just we're finally making this a recommendation across the board for Windows 8. We're also asking that you secure any private key, any platform key you may need to create. It's important, it's vital that you secure your private key, the portion of the platform key that is private, in some fashion that is specific to your business. The public portion, of course, is okay to distribute. Only the public keys go in the firmware, and obviously determine the best strategy to secure the keys and to meet your needs. Standardize on a common set of tools. If your manufacturing line uses 128, 130, 200 set of tools that are different, consider reducing the number of tools, combining different tool sets to do multiple tasks, really just trying to reduce your overall support costs for the different set of tools on your manufacturing line. And overall, we feel, and we have proven with some OEM engagements, that longer term there will be a reduction in costs associated with this migration towards UEFI and towards Windows 8. It was our pleasure to also host AMI and Nurul Wu from AMI in his presentation. This portion of the presentation at WES was given in Chinese. I will recap just a few slides from that session, which was done in Chinese, to kind of spell out some of the highlights of that session. Please review their debugging solution, their discussion of how they chose to design secure firmware updates. It's a very interesting portion of the presentation. And there's also some discussion about how you provision keys and assigning server in an ODM factory floor process and environment. And then finally, there's a discussion about how UEFI impacts the manufacturing process. So let's focus a little bit on the key provisioning as AMI described it. From their point of view, they feel that the initial factory firmware default should provide the default essentially variables for the security databases into NVRAM. So they've essentially opted to recommend the concept of baking it into Flash, and that's perfectly acceptable. Updates to the KEK and the DBX can then be done from the shell environment, whether it's a UEFI shell or Windows 8 PowerShell is up to the OEM and ODM. And the user can also initiate a Apptio-based setup, and Apptio is their product, and that is what they demonstrated in the slide decks. If you review their material, you'll see two examples of what a BIOS screen could potentially look like supported by AMI, and all of our partners are working in this space. We saw examples from many of them. And in this particular example, you can see in the first screen that there is the ability to both enable and disable secure boot, as well as in the second screen, enable and disable certain keys and provision certain keys from removable media and so on and so forth. And also you can enroll hashes, certificates, keys, any of the above, all of the above. It's a really flexible mechanism that AMI has provided the ability for the customer to enroll and manage their own keys. Finally, in closing remarks, our call to action really is about modernizing the manufacturing processes while keeping an eye on costs. Reuse the code where possible, avoiding proprietary tools that aren't really scalable or flexible. Think about debugging hardware during the process. If you encounter a problem, how do you plan to debug it? It's critical that you investigate different solutions that will enable you to streamline the process of root-causing defects on the factory floor. And then lastly, identify the work that is involved in each of the stages of system provisioning. And essentially there's three stages. As an OEM or an ODM, you will obviously receive the bare metal, the blank board, if you will, from your chipset provider. After that, the chipset provider and yourselves and your tools will provision those boards, and essentially that's the point at which you get the motherboards or the systems that essentially go to the retail outlets. And then from that point on, there's a concept of field servicing them. How does a customer update the BIOS on those systems? How does a customer maintain the integrity of that system? And that's the third stage that you should really consider in your manufacturing processes. How do you support that? Perhaps key provisioning as a way to allow the enthusiast to service their own BIOS, while at the same time ensuring that the novice or just the prosumer or the consumer has a system that's secure with UEFI. Those are all options that Microsoft supports, and we can enable you to make through the use of our certification program. Again, thank you for your time. If you would like to visit this session more, please download it from the WES website. My name is Tony, and I'm with Microsoft.